Hello, welcome back to 15-Minute Math. So earlier we learned the derivative of a couple trig functions, sine and cosine, but we didn't go over any of the others. We kind of left those be, didn't make any comment about those, and I think now is the time, now that we've learned some of those other rules for derivative, I think it's going to be time to actually go over the derivative of the other four trig functions. And so let's just go over, so maybe we should learn not really learn, maybe we should review sine and cosine. So if we recall, the derivative of sine with respect to x is cosine, and the derivative of cosine with respect to x is sine. I'm sorry, it is negative sine. Now let's maybe investigate this. Okay, then what would be the derivative of tangent with respect to x? And it's not so straightforward, but we just learned the quotient rule. And so maybe we should rewrite tangent as a quotient. You might remember from your trig days, tangent is just sine divided by cosine. And this is helpful because now we can use our quotient rule. So let's do it. Remember, our quotient rule is low d high minus high d low all over the square of what's below. So we have low d high. Well, the derivative of the numerator is cosine, right? The derivative of sine is cosine. So there's low d high minus high d low. Now the derivative of cosine is negative sine all over the square of what's below, so that's all over cosine x squared. Maybe I'll put some brackets there. Okay, well, let's simplify a little bit. Cosine times cosine, that's just cosine squared x. Negative sine times negative sine, that's going to be positive sine squared x. And that's over cosine squared x. So one of the few times we're not going to split our monomial divisor, because notice that the top is a Pythagorean identity. Remember, cosine squared plus sine squared is equal to 1. It's one of those identities you learned in trig class. So we get 1 over cosine squared x. And now we have to think back to our trig class again. Remember, the reciprocal of cosine is secant. So in fact, this is just secant squared x. So the derivative of tangent with respect to x is secant squared. So the derivative of tangent is secant squared. So straight quotient rule there. And in fact, we can do all of the remaining trig functions using quotient rules. So let's do the derivative of maybe cotangent with respect to x. So the derivative of cotangent would be the same thing as cosine over sine. And again, we can just use our quotient rule to work out what the derivative should be. So the derivative is low d high, so sine x. Let's see, derivative of the high is negative sine x. Oh, low d high minus high. Now derivative of the low is just cosine again, right? Derivative of sine is cosine. All over the square of what's below. So the square of what's below is sine, so this is going to be sine squared x. And again, we're just going to clean this up a little bit. So this is going to be negative sine squared x minus cosine squared x over sine squared x. And this is almost a Pythagorean identity in the numerator, but we have those pesky negatives in our way. Let's just factor out a negative 1 from the numerator, and so we'll just make this negative times that. And now we do have that Pythagorean identity up there, so it's just going to be negative 1 over sine squared x. Now the reciprocal of sine is cosecant, so in fact this is negative cosecant squared x. So the derivative of cotangent is cosecant squared. Negative cosecant squared, rather. So it is just the reciprocal of tangent with the added negative there. So we've got two of the four trig functions, two of the four remaining trig functions out of the way. We've got tangent, cotangent. Let's go ahead and do maybe secant. So we'll take the derivative of secant with respect to x. Now, a little rewrite goes a long way. So let's say, what is secant? Secant's 1 over cosine. So that's 1 over cosine x. Zzz. All right, let's see here. I guess it is time for quotient rule again. So we'll go low. Now this is interesting. When I do derivative of the high function, it just goes to 0, right? The derivative of a constant is 0. So low d high minus high d low. Now the derivative of cosine is negative sine all over the square of what's below. Well, that's just going to be the square of cosine. And so this term goes away, right? Multiplied by 0. So in fact, I'm just going to get sine over cosine squared x, which is not the greatest way to write it. Here's probably a better way to write it. Notice that this would just be sine x over cosine x times 1 over cosine x. So I just split the cosine squareds into two different factors here and wrote it this way. And the reason I did that was sine over cosine is obviously tangent. So we'll have tangent here. And 1 over cosine is secant. And so we end up with secant x times tangent. And I kind of flip-flop these guys. That guy went there and this guy goes here. I don't know why. It's just 9 times out of 10, whenever someone asks you, okay, what's the derivative of secant, you hear secant times tangent, not tangent times secant. So I just wrote it the way that you see it the most often. But yeah, there's our result. So the derivative of secant with respect to x is secant times tangent. And last one, we only have one more to go. So the derivative of cosecant with respect to x, which, as we've done for all of these functions, we're just going to rewrite them. So that's 1 over sine and now we're going to use quotient rule. So we do low d high, so low derivative of the high is 0 minus low d high minus high d low. Derivative of sine is cosine all over the square of what's below. So that's going to be sine squared x. And we're going to end up with a very similar result as we did before. You know, we multiply by 0, so that term goes away. We're going to get negative cosine. Whoops, I want to do that in black. Negative cosine over sine squared. But as we did before, we're going to go ahead and just write that as negative cosine over sine times 1 over sine. And it's just a little manipulation to get things into some more familiar formats. So cosine over sine is cotangent. 1 over sine is cosecant, so it's negative cosecant times cotangent. And again, I've kind of flip-flopped the order there. Kind of put this guy over here and this guy over here. I don't know. Like I said, that's just the way you see it. More often than not. All right. So there we go. We have our 4 remaining trig functions, and now we know their derivatives. So we'll go over them one more time, and I'm just, instead of rewriting, I'm just going to kind of scroll And so the derivative of tangent is secant squared. Maybe I should box these or something. There we go. The derivative of cotangent is negative cosecant squared. So you're going to notice that all of the co-functions, their derivatives are negative. Cotangent gets negative cosecant. You should remember that cosine is negative sine. Now this one is not a co-function, so the derivative of secant is secant times tangent. And the derivative of cosecant is negative cosecant times cotangent. Now I don't recommend memorizing a lot of things in math. This is one of the few things I would recommend. Just the six trig functions, you need to just know the derivatives off the top of your head. However, if it comes test time, exam time, whatever, and you have forgotten, okay, I forget the derivative of cosecant, just know that you can just do the quotient rule and you can derive it without too much hassle. It's not like having to go through the definition of derivative to derive the result. It's just a cool little quotient rule. But those are 6 functions whose derivatives I would recommend just knowing off the top of your head.